Hello, this video is for MAC2233, Calculus for Business and Social Sciences. This is Chapter 6, Section 6.1, but the application problems. So the marginal cost to manufacture baseball caps at a production level of X caps is 3.20 minus 0.001 X dollars per cap, and the cost of producing 50 caps is $200. Find the cost function. So they gave us marginal cost. Now remember, marginal cost is the derivative of cost, and we're trying to work backwards to find cost. So if we have a derivative and we're working backwards to find original, that's when we're going to take the integral, the antiderivative of 3.20 minus 0.001 x with respect to x. Now remember, input, output. Currently the input is number of caps and the output is dollars per cap. That's currently. So we take the integral, and the integral of 3.20 will be 3.20x minus the integral of 0.001 x to bring down the 0.001, and then the integral of x to the 1 will be add 1, which is 2, divided by 2. When you take the integral, the dx goes away, and then we can clean this up a little bit and add the plus c. So 3.20x minus 0.001 divided by 2 is 0.0005 x squared plus c. So when we work backwards, now we have costs. So input is number of caps, output is cost. But we have a problem. If I was going to report that this is my cost, and I said plus a number, plus c, probably wouldn't go very well. So we need to find what the c is. So that's why in the problem they gave us extra information that said for producing 50 caps, the cost is 200. Not marginal cost, but cost. Now that we have a cost function, we can say that the cost is 200 when x is 50, so we can solve for the plus c. So we have 200 equals 3.20 times 50 minus 0.0005 times 50 squared plus c. When we simplify this, we get 200 equals 158.75 plus c. That becomes 158.75. So to get plus c by itself, we subtract 158.75 from both sides. So c equals 41.25, which gives us our cost function of 3.20x minus 0.0005 x squared plus 41.25. So again, in review, we started with marginal cost. We took the integral to find cost, but we had a plus c. So to find out what that c is, they had to give us information to solve for c, and then we ended with our original cost function. Okay? Now, another application that we can do is when we look at position, velocity, and acceleration. And we learned in the previous chapters that if your original function is position, and you take the first derivative, you get velocity. And if you add velocity and take the derivative again, which is the second derivative of position, you have acceleration. So knowing all that, we can also work backwards. If I'm starting at acceleration and you take the integral or antiderivative, you get velocity. And if you take the antiderivative or integral again, you would get position. So in this problem, you toss a stone at an upward speed of 30 feet per second. Find the stone's velocity as a function of time, then find out how fast and what direction it's going after 5 seconds, given that the acceleration is negative 32 feet per second squared. And they also give you a hint that the initial velocity is 30 feet per second when time is 0. So we start with acceleration and we're working backwards to find velocity. So we take the integral of negative 32 with respect to t for time. The integral of negative 32 is negative 32t plus c. So our velocity in terms of time equals negative 32t plus c. But we got to find out what c is. So they gave us in the original problem that the initial velocity is 30 feet per second when time is 0. So when the velocity was 30 equals negative 32 times t, which is 0 for time, plus c, we find that c equals 30. So our velocity function would be v of t equals negative 32t plus 30. And then the other second part of the question said, now that you found velocity, what happens at 5 seconds? Well, if I plug in 5 into my velocity function, negative 32 times 5 plus 30, you get negative 130, which is a velocity, feet per second. So what does negative 130 means? Well, the negative means the stone is going downward, and the 130 is how fast it's traveling, the velocity, at 130 feet per second. Now that we have the velocity function, we're going to work backwards to find position at 5 seconds. And we know that at time 0, the stone was on the ground, let's say, at 0 feet. So our velocity is negative 32t plus 30. We're going to work backwards, so we take the integral of negative 32t plus 30 with respect to t. So to take the integral of negative 32t, the negative 32 stays. The integral of t to the 1, add 1, you get 2 divided by 2. The integral of 30 is 30t. And then don't forget your plus c. So your position function is negative 16t squared, because negative 32 divided by 2 is negative 16, plus 30t plus c. But again, we don't know what the c is. So they told us that at time 0, the position is 0. So I go to my position function, plug in 0 for position, and 0 for t, and then we can solve for c, and c equals 0. So our position function, s of t equals negative 16 t squared plus 30t. Then what happens at 5 seconds? Well, at 5 seconds, we plug 5 in for t. The position at 5 seconds would be negative 16 times 5 squared plus 30 times 5, which gives us negative 250 feet. Well, how do you get negative 250 feet? Well, after 5 seconds, the rock is below the ground at 250. So it's kind of like if you're standing on the ground and you threw the rock and it went down a hole or something, or you're at a cliff and it's 250 feet below where you're standing. Okay, that concludes section 6.1, application problems.